This is Unit 12, Lesson 3. We are going to learn about angles and their standard form. We're going to learn about the other measurement of angles called radians, which I mentioned in the last lesson. So this first box is just kind of giving you some definitions and some vocab terms that we're going to be working with. So an angle in standard form always has the first line right here, right on the positive x-axis, and then it opens in this direction, in a counterclockwise direction, like this. So we've got both of these rays right here. The angle in between opening counterclockwise is the angle theta. Okay, so standard form, its vertex is on the origin, one ray lies on the positive x-axis. The ray on the x-axis, this is called the initial side. Kind of think of that as where the angle is starting. The other ray is called the terminal side. Think of that as where the angle is ending. Counterclockwise rotations result in positive angle measures. So that's kind of our standard form, is that we normally rotate in a counterclockwise direction. You can still rotate in a clockwise direction going back this way. That just results in a negative angle measurement. We kind of consider that to be going backwards. One full revolution all the way around, landing back where you started, that is 360 degrees, which I think you guys are familiar with. All right, so drawing the angles. Sketching an angle in standard position. Standard position means that the vertex is at the origin, one of the rays is the positive x-axis. 75 degrees, if this is 90 degrees right here, 75 degrees is going to be just a little bit before that, maybe right around here. And then the angle theta opens up in a clockwise direction. So this angle would be a 75-degree angle. If we look at number 2, negative 160 degrees means you still are at the origin, you still use this as your initial side. This time it's going to open backwards though, which means going clockwise instead of counterclockwise. So backwards 90, backwards 180. So backwards 160 would be just a little bit before that, like maybe right here. So this would be going backwards, and that would be our angle, 160 degrees backwards. 430. 430, we still start at the origin, we still use the x-axis as our initial side. 430 means we go around once and then we go a little bit more. Okay, so 430, if we subtract 360 degrees, it leaves us with 70 degrees. So it means we do one full lap and then 70 degrees more. So we do a full lap, that would be 360, and then 70 degrees more means we go right around there. Okay, so that would be 430 degrees. Just kind of keeps going around. Next, we are going to introduce a different measurement called radians. So think of radians versus degrees as like centimeters versus inches, or kilograms versus pounds. Just a different way to measure the exact same quantity. And that quantity is an angle. All right, so radians, they come from the arc length, and arc length would be like this measurement right here, which is something you guys probably did in geometry. All right, so 1 radian, I'm going to read this definition. 1 radian is defined as the measure of the angle formed when the radius is equivalent to the length of the intercepted arc. Okay, so this radius right here, the intercepted arc is this. So at some point, you're going to be able to find an arc length that's the exact same as the radius right here. So when this measurement is the same as this measurement, we consider that to be 1 radian. So if you go all the way around, the circumference of a circle would be 2 times r times pi, or 2 times pi times r. So if we go all the way around, that would be 2 pi radians. Okay, so that means if 2 pi radians is all the way around, 180 is halfway around, so half of this would just be pi radians. Okay, so again, this r is the same as this r right here. That means this angle is 1 radian, like 1.00 radians. So the circumference of the circle, like if I go all the way around right here, all the way around means I am multiplying this by 2 pi. And if I multiply 1 by 2 pi, what I end up with is 2 pi. So that's the measurement for all the way around. So 2 pi is like 6 point something. So this, we now have these conversion factors down here. And you guys have conversion factors for going from centimeters into inches. You have conversion factors from going from pounds into kilograms. So we have a conversion factor that takes us from radians into degrees and then back from degrees into radians. So converting from degrees into radians, if you are currently at 360 degrees, you want to turn it into 2 pi radians, what you do is you multiply by pi over 180. So you take the measurement in degrees and you multiply by pi over 180. So let's try those first. If you're in degrees, you want to get into radians. So let's look at number 4. We take the measurement in degrees, which is 30, and then you multiply it by pi radians over 180 degrees. Pi radians over 180 degrees. And then anything that can simplify should simplify. So 30 over 180, you can divide those both by 30. So this is 1 and this is 6. So 1 times pi is just pi. The denominator would be 6. So this measurement in radians would be pi over 6. Okay, so pi over 6 ends up being a sixth of this. So going a sixth of the way from here to here, which makes, sense for what 30 degrees would be. Let's also look at number 6. This is a negative measurement. So we take the degree measurement, according to this formula right here, and you multiply it by pi radians over 180 degrees. And then we reduce as much as we can. So we know we can reduce down by 10. So those zeros will cancel. And then 22 over 18, we can reduce those down by 2. So reduce this down by 2, I have 11. Reduce this down by 2, I have 9. And I think that's as far as that will go. So I have negative 11 pi over 9. Okay, so that's how you go from degrees into radians. This next section, you can go from radians into degrees. So it's just the reciprocal here. Pi over 180 becomes 180 over pi. Okay, because this, if I want to get degrees by itself, I divide by pi over 180, which means multiplying by the reciprocal, which is 180 over pi. So each of these that I have, let's do number 8. Number 8, you have negative 5 pi over 36. You take that radian measurement, and you multiply it by 180 over pi. So what should end up happening with each of these, the pi's will cancel out because you don't have pi in your degree measurement, so it's just degrees. And then anything else can reduce down. So 180 over 36 can actually reduce down evenly. So dividing this by 36, we could start, you could reduce it down little by little if you want to. You can reduce it down by 6, reduce this down by 6, and then you might notice that the 30 over 6 can continue to reduce. So divide by 6, divide this by 6, and then it's completely reduced. So negative 5 times positive 5 would be negative 25, which is given in degrees. And one more on this page, let's take 7 pi over 4 and convert that into degrees. So you take your radian measurement, which is 7 pi over 4, multiply it by 180 over pi. So first of all, you should always notice the pi's canceling, and then 180 divided by 4 reduces down evenly. When I divide this by 4, I'm left with 45, and this 4 will cancel. And 7 times 45 is 315 degrees. All right, so that is your quick little introduction to our new measurement called radians, and we're going to be working with that a little bit on the next page. So next page, we're going to talk about something called coterminal angles. Coterminal angles are those that land in the exact same spot. So this is actually a good example. 430 and 70, we would say those are coterminal because their terminal side would be in the exact same spot. So that's what our definition is. If you have a different angle measurement, like let's look at number 10, 65 degrees, we can find 2 other coterminal angles, one positive and one negative. So to get the positive one, you say, all right, I'm at 65 degrees. Let's go another lap around the circle. So you take 65 degrees and you add on another lap, which means adding on 360. So that lands you at 425 degrees. So if I did 425 degrees, I do one full lap and then 65 degrees more. So these 2 would land in the exact same spot, which makes them coterminal. And then if I take 65 and I go backwards 360 degrees. That leaves me at negative 295. So if I go backwards 295 degrees, it lands me in the same spot as going forward 65 degrees. Let's also do a radian measurement. So this is 13. So I go forward 2 pi and backward 2 pi instead of going forward 360 and backward 360. So I take this and I add 2 pi to it. So for 2 pi, I can think of that as 18 pi over 9. So 18 over 9 is the same as 2. I do that just so I can match my denominator here so that I can add them together. So 14 pi plus 18 pi would be 32 pi over 9, my common denominator. So that would be coterminal in a positive direction. Or I could take that 14 pi over 9 and go backwards 2 pi, or backwards 18 pi over 9. And then this one, 14 pi minus 18 pi, is negative 4 pi over 9, my common denominator. So same idea, just in radians instead of degrees. All right, next topic, reference angles. So reference angles we've been talking about a little bit in the last couple sections. The reference angle basically tells you back, or takes you back to the x-axis. So the angle formed by the terminal side and the x-axis. So if it goes this way, this little guy is your reference angle. So your reference angle should always be somewhere between 0 and 90 degrees. Okay, so your reference angle should always be somewhere between 0 and 90 degrees. So 225, origin, positive x-axis. This is 90, 180, and then 225 would be back this way. So this measurement right here would be your reference angle. So from 180 degrees to 225 degrees, this is a difference of 45 degrees. So our reference angle would be 45 degrees. Okay, let's look at negative 310. Origin, positive x-axis, I can go backwards 90, 180, 270, and then just a little bit more. So this, remember, you're always going back to the x-axis. So that would be this measurement right here. So if this is negative 310, and this is 360, so going backwards 360 would take you all the way. This is only backwards 310. So that means I have 50 degrees left to go. So that would be my reference angle. 2 pi over 3. Okay, so 2 pi over 3, I want to turn that into degrees first. So I multiply by 180 over pi. The pi's cancel. 180 over 3 reduces down to 60. So this is the same as 120 degrees. So let's sketch it out first. So origin, axis, 90, 120, 180. So that would be our 120 right here. So we want this measurement. It's always the axis formed by the terminal side and the x-axis. So it's this measurement right here. So in degrees, it'd be the difference between 120 and 180, which would be 60 degrees. But I want to make sure that that is done in radians. So think of this as pi instead of 60, or instead of 180. So I do pi minus 2 pi over 3. Excuse me. So this is 3 pi over 3, just to get a common denominator. So I subtract that and I get pi over 3. All right, last topic I'm going to look at is doing trig functions in terms of x and y instead of in terms of opposite, adjacent, and hypotenuse. Sorry. So theta is the angle somewhere in standard form, and then you can find a point somewhere on the terminal side. So that point is P. So then from P to the origin would be R, and we can use the Pythagorean theorem for that. So instead of a squared plus b squared equals c squared, we're going to use x squared plus y squared equals r squared. So same exact idea, just looking at it on a coordinate system instead of looking at it as a, b, and c. So sine, if this is our angle right here, sine would be the opposite over the hypotenuse. So that would be y over r. And cosecant is the reciprocal, so it'd be r over y. Cosine is the adjacent over the hypotenuse. Secant is its reciprocal. And finally, tangent would be the adjacent, or I'm sorry, the opposite over the adjacent. So y over x, and cotangent is its reciprocal, so x over y. So one final type of problem, I know this was just kind of a big mix of all sorts of different things, but one final type of problem is something like this. 5, -2 is a point on the terminal side, so plot that first. 1, 2, 3, 4, 5, -2, so that right there would be a point on the terminal side of an angle in standard form. So this is our angle in standard form. Find the exact values of the trigonometric functions of theta. So we know that x is equal to 5, we know that y is equal to -2, and so we can find r using this formula. So we have x squared plus y squared equals r squared. So 25 plus 4 is equal to r squared. Add these together, we get 29 is equal to r squared. And so we take the square root of both sides. And 29 does not reduce at all. We know normally there would be a plus or minus, but here we're only considering the positive side. So that is r. All right, so we have x, we have y. R is considered to be a distance, so it's always going to be positive. All right, so let's fill all of these in. So sine would be y over r. So the y coordinate over the value of r. And then I know I can rationalize, so multiply the top by the square root of 29, multiply the bottom by the square root of 29. Cosecant is the reciprocal, so I would flip this version of it. So root 29 over a -2. Cosine is x over r, so the x coordinate is 5 over r, which is root 29. And then I can rationalize, so multiply the numerator by root 29, multiply the denominator by root 29. And secant is the reciprocal, so flip this version, root 29 over 5. And finally, tangent. Tangent is the y value over the x value. Y value is -2 over the x value, which is 5. Cotangent is its reciprocal, so 5 over -2.